The last thing that we need to calculate is the mean and standard deviation for a binomial random variable. So if we had some binomial situation and we wanted to find what a typical value would be in this distribution, we can calculate the mean. And it should be somewhat intuitive. You take the number of trials and multiply by the probability of success, and that's going to give you how many successes you would expect to find. Now the standard deviation is a little more work. You have to take the square root of n, the number of trials, p, the probability of success, times 1 minus p. So if you need to make a note, n is the number of trials, and p equals the probability of that success. So let's look at example 6.3. So we're looking at the 2016 Computer Financial Literacy Survey, and it estimated that 40% of U.S. adults say that they have a budget and keep close track of their spending. Now this was based on a representative sample of more than 1,500 people, so it's probably a good estimate for the percentage of all U.S. adults who have a budget and keep close track of their spending. So we're going to let that be our success at 40%. And let's say that we take a random sample of 25 adults. How many would we expect out of that group of 25 to have a budget and keep close track of their spending? Well, it's going to be the number of trials. So mu here is going to be the number of trials times the probability of success. So we would expect about 10 in our group to have this budget. Now, if you get a decimal, it's fine. Don't round it. Well, round to maybe 1 or 2 decimal places, but you can have a decimal here. If you've ever heard people joking about, graduating college, getting married, and having your 2.5 kids, you can't have 2.5 kids, but where that comes from is that the average number of children for married couples is 2.5. There's certainly some with none, 1 or 2, but then you have some couples with 3, 4, 5, or 6. The average number of children is 2.5 for an American family. So that's where that comes from. It is absolutely okay for your mean here to not make sense in terms of having part of a person, because this is just a statistic. Now the standard deviation here, sigma, is going to be found by taking 25, then times 0.4, and then times 1 minus that, which is 0.6. Let me do that quick calculation. And we get 2.45. So we would expect a standard deviation, so a typical deviation from the mean, of about 2.5. So if you have to find the mean and the standard deviation for a binomial distribution, just use these two formulas.